In order to understand what Kubernetes is, let's go back to the picture we drew a moment ago. We said that back in the old days, we would develop apps on top of a native operating system, which in turn would sit on top of bare metal infrastructure. Then virtualization came along and we started to develop apps inside virtual machines. Those virtual machines had a guest OS. Each of those virtual machines ran on top of a hypervisor, which may or may not have a host OS beneath it, and which in turn interacted with the underlying infra. Then came along containers. Containers were even more abstracted. We gave the analogy of how a container is kind of like a jar file. It's an executable which includes all of the dependencies required for it to run. For a container to run, clearly there needs to be some level of abstraction that is provided by a container engine like Docker. Just like Java jars need to run on top of the Java runtime, containers such as Docker containers need to run on top of the Docker runtime. Let's now take this analogy one step ahead. What if we need a large number of containers running on different pieces of infrastructure? And what if we want to provide specific functionality such as auto healing, auto scaling, and load balancing? This is where we need another piece of software, an orchestrator, and that's where Kubernetes comes in. This role is analogous to that which Hadoop plays in the world of Java jars. Hadoop takes a large number of nodes or individual machines running Java and converts them into a cluster. Just like that, Kubernetes takes a large number of nodes, each of them running Docker or Docker containers, and converts them into a cluster. The beauty of Kubernetes and the reason why it's becoming so popular is that it makes it possible to set up those same services of auto healing, auto scaling, load balancing, isolation, orchestration across thousands of containers running on potentially hundreds of nodes, and it does so in a manner which is platform independent. We are increasingly moving to a world in which development is going to take place in multiple different environments. The most likely scenario for compute in say 2 or 3 years from today is that companies are likely to have their own on-premise data centers which will be pretty small and maybe used only for experimental purposes. They will almost certainly have at least one large installation running on a public cloud such as AWS from Amazon or Azure from Microsoft or GCP from Google. And very likely they are also going to want to be multi-cloud. That is, they are going to not want to be tied to a single cloud provider. You only need to look at some recent facts such as Amazon's acquisition of Whole Foods in order to see why it's not prudent for any company to be entirely beholden to one cloud provider. If we now move back to yet another diagram that we drew a moment ago, we shall see that the two extremes, either infra as a service for compute or platform as a service for compute, neither one of these two extremes is likely to be ideal. Our best bet in such a hybrid multi-cloud world is likely going to be containerized workloads running on top of Kubernetes clusters. Kubernetes has emerged as a clear winner in the container orchestration space. It has been adopted by AWS and Azure. Remember that Kubernetes came out of Google, and to that extent, Kubernetes has something of a special relationship with the Google Cloud Platform or the GCP. The GCP is hardly a leading player in the cloud world right now. In terms of market share, it's maybe number 3 or even number 4, but it definitely has a very important role, and that important role can also be tied to the dominance of Kubernetes in container orchestration.